Right. Given numbers of processing can return the average value of all even values that are divisible by 3. Round down to nearest people and yes, integer. So 3, 6 even. Right, just add. If S still need a count. Yeah, that's a division by 0. Oh, just each case need to carefully. And most popular video creator to string array, integer views, Anson, Anson, IT views, beauty is the sum of numbers of views on all creators. If multiple creators have a highest priority file of them, smallest ID, 2D arrays creators has the highest and IDI is their popular video it's in any order. So Alice have 1 and 3, right? So sum of the view is 10, and Bob also have 10. Most popular video. For Barb, the video has video count is 2. For Alice, since 1 is legible smaller than 3, so let's include the answer. Alright, so girls written most popular creator and video. So I want to use its there's a hash table. Record the creators and the views. Creators main ID is here. Return this, so I need 3 parts. This is resource. And parentheses send. Also need a map. This is the total views. Total views creators. I will add about views. I also need a maximum. Okay, so and we also need another string is the main IDs here. Main ID. Count creators, I, and account. Creators is IDs I and main IDs I. Creators is main. IDs I. Alright, and we also need a maximum views. Alright, so for send if total views pushback okay, that's it. Oh wait. So oh wait, sorry, still need the video is high speed. So probability of total should be highest and okay, so alright, so views. Highest views. Alright, I was thinking about the highest views and each video. Know if creators I if highest views should be greater. Views I means and this is the set. doesn't matter. Alright, we can try to use is that or the view is a send. And the main IDs. It's smaller than IDSI. Means and that means it should be how this view says as its view size. Main ID says. Alright, that's it. B and C. So yeah, wait, select what happened when you were this down? Hey. No response. Alright, so problem 3 is you're given two possibly indicators and target. Or indicator counts in beautiful sub-digits less than equal to probably minimal non-negative indicators, such that n plus x is beautiful. The input will generate also have to make always possible to make beautiful. Alright, so SP, POP2, S1, S3. A 0 and let me be 0. So sad here. So they said why so they wait a moment. This should be here. So to check if this is empty. Yeah, it should be okay. Should be okay. What? Why? Which I don't understand. Oh. What? So still be here. Wait. Oh, wait. So much error here. Oh, constraint. You be careful this. So still be. Still be. Alright, so how do you make beautiful? Sum of a digit. So first thing you need to know beautiful. It's sum of digit and less than equal to target. And you want to find out that this is beautiful. So make the integer beautiful. Okay, so if this is okay, so idea is add from lowest digit and the digit sum digit sum at about the 10, right? And what should we do? If this is 9, okay, so we will add right, so I use the sum digit, calculate digit, and given a long x, we will try to do its right, so calculate digit. So well, calculate digit is greater than target. Alright, so we can do this. It's greater than target. Now we are limit the last. Now we will do here is that it's answers. Okay. Alright, so we add the last digit is 6. And we add 6. Mode base. Seven. And this is the add. Last digit. We add x and become 4 and 20. And now the base should be going to be yeah, that's it. That's problem. Nice. So given the root And you also want to create queries and perform independent queries on the trees. Remove subtree root. Subtree root and node values query from tree generate queries will not equal to the value of a root. What it means? Insert size and the height after performing ice query. So given this example, query is 4, we remove it, and height is 2. Alright, so queries is an integer. Subtree. The generate queries will not be equal to the value of a root. Okay, so can we do the queries? Similarly, the process is not allowed. Okay, so queries to each queries remove the subtree. And set here and calculate the height. And okay, so I may have some idea is that because the just thinking if we 4 and 6 7 1 and if each query remove 3, this is simple. If we remove 2, the depth is none. If we remove 6, what is idea? Queries here. This is 4 after removing. Because this is independent, so consider if we remove 7, we will remove the height. I may have some idea. Maybe we can use this remove from child and do a query. of each node, and do the query. Since the value is unique. Okay, so it generates some constraints that all the values in tree are unique. This is important. And right, so what is the idea? If we remove 7 and remove 6, doesn't change. Remove 5, doesn't change the answer. And okay, let's see. 5 doesn't change the answer, but remove 4, we will change the answers because this is the hardest part. If right, and it's sing. If let's say if we remove this maxima, think. So for example, let's say this is from this path. From this path, the height is 2. From this path, the height is 3, right? And if this is not equal, and we remove 4, then the height will be this. Okay, so the only thing you need to care is that if you have 2 highest node and no matter how you erase, it doesn't change anything because if this 2 has the same height, this table don't change anything. So I may have some idea. So we know this is not the same height. This is not the same height. And you need to think when you erase not a maximum. So each label we will get its label node, and we need to think so in this example, if we remove 6, because this is not a maxima and the maxima count is smaller than 2, so we don't change anything. Okay, so I need some information. First thing you need to know, we need to know label information. And we need to know this table, how many maximum depths, how many maximum height. In this example, say level 4 we only have 1, so this is a critical node. And for this case, let's say we only have 1. This case we only have 1. So all this is critical. And if we have 2 more critical, then remove this node, doesn't change anything. So I want to use step 2. I want to use our map and sync leveled, we will have the node and the critical. For example, we also need to calculate the node and decrease the height. Right, so first thing we can calculate the height. Then need easy traverse, right? So node height right, and return maxima. Height, root, left, yeah, it's the height. And you also know the level information, how many maximum height in this. For example, let's say this is, in this node this is 2, this node this is 1, in this node this is 1, and this node this is so, and I think this is, so we also use our map. It's a label and the node value, and the node information, right? So node information, so need label and the node. Okay, or we can just use the level information. Okay, so that's it. You know, the set is like this label. First thing is 1. So 1, 0, 1, or we can start from level 0. So label at 1, label at 1. And now this is the map. Set label and how many level nodes. So as I said, level information is not how many height, it's it's you need to know wait, rethinking it again. Right, so if the height it's not if the same level we have multiple maxima, that is okay, right? So get it. Right, sync. will be a return. And this is the node label, and what happens here, we know the send label, and we also need to know this node height, this node height, this node height. So we can build the height. So also need the height. Also need the edge. This is a node height. And and also the height 0, 1, 2, 3, 4. It's the the node. It's going to be a resource. Yeah. And this. Alright, so build the height. And now that's step 3. Now step 3. Node height. Right, it's not step. So this is step. Right, so this is step 3. Calculate node will decreasing, and now let's move to its Alright, so we have built our information, and step 3, level by level, from bottom to top. Right, from bottom to top. Right, so yeah, and now I'll calculate the answer. Okay, so we have built the information. This is done. We'll get all the information here, and now what I'm trying to do is that for labels here. So int total height. Now we are trying to do alright, so let's say we also have the answer on the map that is decreasing. So be the answer. This is total height, right? Now for each query, resource will push back the height root. No, we can make sure that the root always have 2. So root no minus this is negative. So right. Okay, so yeah, let's try to do this. And now what we're doing here is that for each level, so level 4, and we'll get at how many nodes here. So the nodes reference map level is node size is 1, means this label it's critical. So it is critical. So the answers of the nodes any begin should be 1, decreasing 1, and decreasing the this value. So we're decreasing total minus else, let's say the h value nodes and h values push back the height, right? So the height, and as we know, count. This is maximum. Okay, so if it's greater than maximum, means count at 1, and maximum is going to be hx. Count is on 1, and now if maximum is 1, if maximum is 2, we don't change anything. The count is 2. So if the count is 1, means greater than 1. So we only need to care is that we're all decreasing is 0 because this is not a critical point. So we only care is that for this node, if the height it's maximum, it means this is the critical node, and the answers else we don't do anything. No critical node. Yeah, so do nothing, right? So this will be answers. X should be total minus add 1. For this example, say this is 5, and we will decreasing to decreasing 1. This will decreasing. Oh, so how do I know the second maximum? How do I know the second? Yes, how do we know the second maximum here? So you also need to know the second maximum. Decreasing the height, how? Because, yeah, well, I need to think. It's not wrong, it's not correct. Right, so it's really hard because if this node only 1 means it's like this, and if this is 2, we minus this label. So yeah, this can make sure if the label is 3, label is 2. So it's a total is 3 minus 2. Add 1, so we minus 2. Yeah, exactly true. But if okay, oh wait, I know what happens here. So if count is 1, it means what is the second maximum? Count is 1, and right, so I need values. And yes. If count is 1 and count is 2. Actually, we should use that. Oh, so dirty here. Now here. I have some idea. Alright, so if values that answers values 0, the second will be total and 7 1. Else is greater than 2, And the second height, it will be the maximum, second maximum, so it's total. So we remove the first will be the total minus the difference, right? So the difference, its values first values 0 first minus. So we don't do this, and yeah, so it can be general, it can be general, it can be general, it can be general, right? So should be work. Wait, so if we erase 4, in this case it's because this is critical, and the difference between this and this 3 and 2. This is 3, this is 2, so decrease 1. So this will decrease. Wait, what? The size is 1, total minus 1. Otherwise, it's first minus second height difference. We sort by height, so the maximum height is maximum height and x. So x. Okay, weird. Actually, this height is 3, right? So the 4. The height as labels total. Okay, only see the case 1. Should we have 562 and a 4 3. Okay, not a 4 3. The height is 3 and 2. So wait, the total should be 4. So 4 minus 1 is wait. Label is 4, and the root value it's why not just use total minus this. What? Wait a moment. What is the total? Weird. What is the total? Total and I check Q. Oh, it's not. Alright, it's answers, right? So 41, yeah. So decreasing 1. Answers. Okay, so yeah, it's yeah, that should be work. All right, that's it. All right, so yeah, so yeah, it works. It's done. Took a lot of time wasting for doing something. Yes. All right, and actually, decreasing the height, it can be generalized. All right, so that's a problem 4. It's not a hard problem, but all right, a little hard, but yeah, it's nice problem, but it took a lot of time. All right, so I need to see my summation. Is it make sense or not? Actually, I think it should be make sense. A little tight, but it should work. It should work. It should work. It should work because yeah, overall time capacity is analog and it's doesn't use a lot of space. Yeah, it should work. Alright, so that's alright, so okay, this problem now. It took some time. So still be here, but yeah, you know, that's so still be. Okay. Alright, let's see the problem. So fast here. Yeah. I think my approach is correct, but I still took a lot of time to tackle this. The speed should be increased. Too slow. Doing too slow. Yeah, it's not that hard, but problem 2 took so much time to debugging. I hated 3 penalties. And yeah, the math problem. And it's yes, another interesting problem, but should care for that because the value is unique, so we can use this. If the value is not unique, now I need to think removal should be we may we may erase a lot of trees. So, all right, let's see this problem. Problem 1, it's simple, right? So you need to add, you need to calculate the average value of event values and also be divisible by 3. So actually means that they should be divisible by 6 actually. It's just divisible by 6. It's almost the same thing. Alright, so yeah, but yeah, and yeah, that's and we just for loop and calculate how many divisible by 6 and add and just divide it. Careful the if we don't have anything, there should be divisible by 0, so you care for this. Okay. Problem 2. Right, so problem 2 is, I think the problem statement is not very clear. You need to calculate the creators and videos and IDs, views and IDs, and you want to sum up the probability of the creators. It's the sum of numbers of view of all creators' video, and you also need to find the highest probability and its most viewed video. So yeah, so you need to find each creators. And you need to find each creators their most viewed video. And the most viewed video is that multiple creators have the highest priority. Yeah, oh, sorry. So we want to find the highest probabilities, and also you need to find each video, the most viewed, and the IDs. Alright, so just simulate it, and you calculate the maximums of the total view, and also you need to calculate that each creator, what is the most viewed video. So this thing is do most video and the IDs here, most video and the minimum IDs here. And now let's go. So for loop is that we check the maximum total views and care for the sum of the total views will overflow. So yes, this should be careful. Let's say edge case. And careful that if the sen and min ID is empty or min ID is too big, that can be updated. Okay, so just careful these two things. You will get it. And that's problem 2. It's not that hard, but just need to careful. And this problem. So it's a minimal addition to make integer beautiful. And actually it's that the beautiful means that the sum of the digits is less than or equal to the target. And you want to find the minimum non-negative integer x. So actually, if this is already smaller than target, so we don't add anything, right? And since the constraint x is very big, the n is very big, and so you need to think, how do you do that will make addition minimize, right? So actually, you very initially idea is that we add from the smallest digit. In this example, if we make this digit to 2, 0, that would be smallest. If we make 1 to 0, that is not a good idea. So you actually, because you erase this is the smallest, and let's consider this is 6, right? So 7. Say the target is 7. You have 2 digits, right? And now if we choose this digit, we will become this. But it's not good, right? Because if we choose the last digit, we'll only get this 7. It's good, right? So yeah, so so you always choose the smallest digit, and we just simulate it, do the smallest digit until this is smaller than target. And yeah, let's just simulate it and calculate digit. This is slogan. Look 10. And the overall time complexity is it's log 10 and square, because this is at most log n times, log 10 n times, right? Because you will erase one digit one by one and you never go back, because this becomes 0, so we cannot do anything. That's a greedy approach. Yeah. So yeah, that's it. That's problem 2. All right. It's problem 2. It's a math problem. It's in gradient math. The problem 4 is, yes, this is interesting, but you need to do it carefully, because the data structure is as like a linked list, so it's very not it's not easy to implement. If you do as alright, that's it's okay. But yeah, this problem is that you need to find you need to answer these queries, and answer these queries that erase the subtree and what is the height of this. Okay, what is the height of this? And because the query is independent, so we don't think on the queries. Let's think, how do we remove this? And important constraint is that all values in the trees are unique. Then what it means? Okay, so you can think from the deepest level, and from the top, bottom to top, and you actually observe one thing is that if this is maximum height, right? So this max height is 2, this height is 1, this height is 1, and if we erase this 2 node, we don't change the answers, right? The only change is we remove this node. But but if we have 2, 1, no matter how we erase in this label, if we erase this 2, the maxima stone doesn't change, right? The maxima doesn't change, so you only carries that from each label. Let's just calculate. Okay, so this is 3, this is 2. So if we erase this node, we will decreasing the height by 1, right? So what is the idea? So first idea is that we need to calculate each node height, each node maximum height. For example, this is 2, this is 3, this is 1, this is 2, this is 1. We calculate the height and record a label, each label, how many nodes in this label, 3 and 4, this label, 2, 6, 5. And we just do from this, we do from bottom to up, and we got the answer. So the first DFS, we just record each label, each node, and we calculate, okay, each node, what is the maximum height? What's the maximum height? Maximum height. Okay, and after that, let's just do this first step. First step is we need to calculate level information and maximum height, and build the information and level by level from bottom to top. And when we are doing this, we also can calculate the label if we erase the node, this node, what happens here. So we also calculate what happens here. And the first thing we need to know is that we need to know the x and the height, right? And we sort it by the largest value. Actually, we don't need to sort, but you can simplify 5 to max. It's actually is enough. But I don't want to find a second maximum, so yeah, so I want to use sorted. You can be optimized, use 2 maximum, 5 to maximum. But they have a lot of case, so we just sort them, and if the value size is 1, that means that they only have one level on one node in this label. So the height will change is just a math. So 3 minus 3 minus 3 minus the steps another one. So in this example, it will minus 1. This example, it will minus 2 if the node is 1, right? So yeah, and so if the height have 2, let's just calculate the difference. So this height is 1, this height is 2, that will decreasing by 1, right? So they're decreasing. And if we have 2 maxima is the same, that we don't decreasing anything, so this will be 0. So this will be general approach, yeah. And after we doing this, we just calculate, okay, what is the height? After query this, erase this subtree, we can use the answer. Alright, so yeah, that's the idea. We only care for the largest value in the each label because if we have the smallest or any other line that is not the maximum, we don't erase. We cannot decrease height because this will do nothing because the height still be go this path. So we only cares in the maximum height path. That's the main idea. Okay, so it's initiative idea, but yeah. But yeah, so that's it. Okay. Alright. Cool. Alright.